Okay, I've hit the timer. Let's crack some eggs. Let me just open my calculator. All right. Crack some eggs. Okay. So number one here is about series. Okay, I'm just going to open the question here. And A says the number of terms in the series. All right, so we can use the formula because this is arithmetic series. So because an is equal to a plus n minus 1d, that means if we want to find the number of terms, we need to make n the subject or isolate for it. So that is an minus a, so the last term minus the first term, divided by d, and then plus 1 after that. So the last term being 254 minus the first term being 2, divided by the common difference, which is 3 plus 1. Okay, so 254 minus 2 divided by 3 and then add 1, we get 85. So n equals 85. B, the sum of the series. Well, that's as n equals, we can do first minus plus last divided by 2 times n. We can use that one. So a, the first term is 2, the last one being 254 divided by 2 and times the number of terms. So that is 256 in the brackets divided by 2 times 85. So that is 10880 there. Okay, that's done for the first one. Easy, right? Number 2. Just gonna have some space here. A, find the first 4 terms in ascending power of binomial expansion of that. All right, so first 4 terms. So we're gonna do first term 2 to the 8. Okay, just write equal there. And then the second term is plus binomial coefficient 8, 1. So the first one is 8, 0. And then 2 to the power of 7. The second one is that to the power of 1. So the sum of the powers here must always add up to 8 for any term, right? And then the next term goes like 8, 2, yeah? And then 2 to the power of, 1 less than before, 6. And then this is minus 5x to the power of 2. Okay, and then the ascending power of x, yeah, that's fine. And then the last term would be 8, 3, 2 to the 5, and then minus 5x to the power of 3. And then we simplify that. So 2 to the 8, 2 to the 8, I forgot, 256, plus 8c1 is just 8. So I'm just going to work that out. 8 times 2 to the 7, 7. And then times minus 5, which gives us minus 5120 x, right? Because we have one x here. And then 8c2 you can do in a calculator, but I happen to know that it's 28. Just 8 times 7 over 2, basically. Yeah, I'm happy with that. 28 times 2 to the 6. And then minus 5 squared is just 25, so we just do that. So that would be 44800 x to the power of 2, don't forget. And then the last one should be a negative because we have 3 minuses here. And 8c3, a little tricky, but I gotta maybe put that in the calculator. So 8c3 is 56. Let me try that. 8 times 7 times 6 divided by 6. Yeah, 56. So that's 56 times 2 to the 5 times, that's 5 to the 3, but note that there is a negative sign. So yeah, well, that's very large. X to the 3, and that's done, I think. Simplest form already. So that's done. B. State the value of x that should be used. This expansion is to be used to find an approximation for 2.05 to the 8. So we just equate the inner function of the expansion there and put it equal 2.05, because if you notice the power is already 8 there, so we kind of can use that, right? So we solve the equation here, so x would be equal to 2 minus 2.0, wait, hang on. Yeah, it's 2 minus 2.05 divided by 5. Let me check if that's okay. So x is a negative value. All right, here we go. So that's, let me clear the calculator, 2 minus 2.05 divided by 5, right? So that's minus 0.01. Answer. Yep. Okay. Yeah. Minus 0.01. Number 3, I gotta use the space here and let you see the question here. Okay, A. Figure 1 shows an open-topped container used for holding water. Container in the shape cuboid made of sheet metal. The base of the container is rectangle 3x meters by x meters and the height is y. Fine. Given that the capacity of the container is 120. Show that the area A of the sheet metal used to make the container is that. Okay, so we are assuming that's the external area, right? And because that is only in terms of x, that means we need to find y in terms of x first. Because we know that the volume is 120, right? So that comes from 3x times y. All right, so y is equal to 3 cancel 120, we get 40 over x squared. That's the y. And now because we want the surface area, so A, we compute the surface area. That comes from 2 of the x times 3x plus 2 of the x times y, and then plus 2 of the 3xy, right? So there are 6 faces, 3 different ones, but so that's why we multiply by 2 here. Okay, so that's 6x squared plus 2x. So y we put in 4t divided by x squared, and then that again, 2 multiply 3, we get 6x, 40 over x squared as well. Okay, so that's, yeah, I get 6x squared. This is 1 over x, so it's 80 over x here. Plus this is 240 also over x. That's why we got that q. So this is 6x squared plus 320 over x as required. And then we're going to use calculus in B to find the value of x for which a has a stationary value. Okay, so in P2, that is done by differentiating a. So dA by dx, we say, is equal to, differentiating x squared, we get 12x, yeah? Differentiating, this is x to the minus 1, right? So imagine x to the minus 1 is on the side of 320 here. So we bring the power down, we get minus 320. And the power minus 1, we get minus 2. All right? Okay? Now, we equate it to 0. Yeah? So we do 12x minus 320 divided by x squared equals 0. Yeah, for that. And we want to find x. So let me multiply that across by x squared, right? So I'm going to get 12x cubed here minus 320 equals 0. So I have x equals cube root. Solving that equation would be 320 divided by 12. And here we have to cube root that. All right. So giving you answer to 3 significant figures, that implies that we should do the calculator here. So 320 divided by 12 to give me 2. This is 3 sig fix, right? So I'll put 2.99. Yeah. All right. Find d squared a by dx squared. Yeah, we just differentiate dA by dx again. Basically, that's the second derivative. So we differentiate that whole lot again, which is 12, what was it? 12x minus 320 x to the minus 2. Yeah, we're differentiating this again to get the second derivative because that was the first derivative, yeah? This guy. So we get 12 alone on that because x goes away. And bringing minus 2 down, we get a plus here, and that thing becomes 640. X, the power minus 1, we get minus 3 here. And hence show that the value of x found in part B gives the minimum. So we sub x equals 2.99. I'm just going to do exact value, yeah? Just in case. So we get d squared a by dx squared equals 12 plus that. And as you can see, this is still also, if we do 320 over 12 to the power of 1/3, right? That's going to play some trick there. So I have this to the power of 1/3, all to the power of minus 3. Yeah, so basically this is going to cancel 1 over 3 times minus 3, that's minus 1. So it's going to be flip the fraction instead. So we get 2 here. That is 26 plus 12, we get 38, which is greater than 0. Therefore, d squared a by dx squared greater than 0, indicating that this is a minimum. Okay? As required. Okay, here we go. That's it. Question 4 now. I'm going to use space here. Given that in particular geometric series, the sum of the first 3 terms is that, the sum to infinity is that. All right. Okay. So sum of first 3 terms, that means we have, let's say we have a for the first term, and then we have AR, and then AR squared, right? Because we multiply the next term by R, keep doing that, that's geometric. So that means for A we have, for the sum of the first 3 terms, we have A plus AR squared would be equal to 70.2. Okay, so that's like, if we factor A out, we get A in brackets 1 plus R squared equals 7.2. I'm just finding that first. And then sum to infinity, yeah, that is the formula A over 1 minus R. So A over 1 minus R is equal to 75. Okay? So let's see what we can do with this. So if we rearrange this, we get 75. A equals 75 times, in parentheses, 1 minus R. We could, if we want, substitute this into A here. But let's see if there's any alternative method there that I can see. Or we could substitute R in terms of A. Probably that's not going to be wise. Okay. Okay, so this is a cubic equation indeed. Seems like I need a... Okay. Seems like I need a calculator there. Let's see. Wait, or we can do something else with the sum there. Okay, let me try something else for the first equation. Because we could have done Sn equals A times... Yeah, that's like, that was the other formula, right? So it's A, what was it? 1 minus R to the n divided by... So this would be 3, right? Because to the third term. And this is 1 minus R, right? Yeah, it could be that as well. Equals 70.2. You know what? Let's actually use that because I just see something, yeah? Okay, so I'm just gonna maybe delete these thing, just not to confuse any people. later on. Okay, so if I substitute this into this fraction, I should get 75, right? So that means, okay, let me write this first. I can rearrange that into a over 1 minus r times 1 minus r cubed equals 70.2. And I can sub this from the infinite series into that. So therefore, considering two equations, we have this. Yeah? Just substituting this into this whole thing. Aha, so 1 minus r cubed will become 70.2 divided by 75. So 1 minus r cubed equals 0.936. So we do 1 minus that, we get 0. So r cubed equals 0.036. So r would be just, oh no, just the cube root of 0.0363. So r equals 0.4. Okay, so that's the common ratio, guys. B. The first term. Okay, that's not hard now. So we just substitute r into the maybe the infinite part here. So a over 1 minus 0.4 would be equal to 75. That means a equals 75 times 0.6, just solving the equation there. And we get 45. Yeah. So a is 45. That's not hard. Next question, number 5. All right. Gonna do a here again. Given the function f there, and where a and b are constants, given that 3x minus 4 is a factor, so this is factor theorem. So whenever we are given a linear factor like that, we can just substitute the critical value. So the critical value can be found by just put 3x minus 4, which is the thing in the brackets there, equals 0. So critical value is 4 over 3. And we put 4 over 3 into the function. Yeah, and put it to 0 basically, right? That's power 3. 4 over 3 squared minus 10 times 4 over 3 plus b, right? Yeah, we put it to 0, yeah? Put it to 0. Okay, so okay, I need to be thorough there. So 3 times 4 over 3 and then cubed plus, oh no. Okay, hang on. 3 times 4 over 3 over 3 cubed. So I need to find one by one maybe. So that's 64 over 9 plus, this is 16 over 9. I just know that. That's fine. Wait, that's a, sorry. This is minus 40 over 3 plus b equals 0. Okay. We multiply by 9, so we're adding up this first. So this is, okay, I'm going to write 16 over 9a plus b, and this constant term, multiplying the denominator by 3 and the top by 3, we get minus 120. Minus 120, so that's 56. So this is minus 56 over 9 equals 0. Multiplying across by 9, we get 16a plus 9b equals 56 as required. B, sorry. Given further when fx divided by x minus 2, the remainder is b. Right, so we're going to do f2 now, and the remainder will be put to b, right? So this is 3 times 2 to the 3 plus a times 2 to the 2 minus 10, 2 plus b equals b. Yeah? So b cancel here. And then what we have here is just 3 times 8, 24, plus 4a on the second term, and minus 20 equals 0. So that is another equation to solve simultaneously. But we already know a, so to speak. So this is 24 minus 20. We get 4. So that is 4a equals minus 4 on the other side. So a is minus 1. All right. So if a is minus 1, b would be substituting back into this equation. Yeah, so it's 56 minus 16a, but a is minus 1. So that would be 72, yeah, for that. Okay. C, now we want to fully factorize fx using algebra. Okay. So we know first that it is quadratic. This one is a factor. I'm just going to do that. And then let's do ax squared plus bx plus c equals 0. No, equals the original. Yeah. Which is 3x cubed plus, because a was minus 1, so this is minus, sorry about that, minus x squared minus 10x. B was 72, so that's plus 72 equals, yeah? So we are comparing coefficients. So if we just do the first term and the first term, we should get the cube term here. So we do 3 equals 3a. So that means a equals 1, just comparing the terms. And then where's another b? So b, we can do the x term, which is 10 on the left side. So I do minus 10 here equals. We just pair up whatever pairs we get for the x term. There is one here, 3x times c, yeah? So I'm going to do 3c here, the first one, because we want to get the x term. And the other one is minus 4 times bx. So that's a minus 4b without the x. Seems like this doesn't help. So we're going to go another one to find c first, maybe. So it's 72 minus 4. 72 times minus 4. 72 equals, sorry, minus 4 times c, sorry. Yeah. So c equals 72 over minus 4, and that is, I believe, 24, 23, wait, what? 18, yeah, 72 divided by minus 4, minus 18. And if c is minus 18, that means b would be minus 10 plus 4, wait, what? No, sorry. Minus 3c, where c is minus 18, divided by minus 4. That's right, yeah? Okay, so we have what? Minus 10 plus 3 times 18, because minus minus cancel that, and divide by minus 4, so we get minus 11. All right. Yeah, we got a, b, and c now. So that means fx can be factorized to be 3x minus 4. And then big A is 1, so that's x squared. B is minus 11x. C is minus 18, yeah? That's it. Okay, fully factorized. Cool. Next one, number 6. This whole thing. Circle equation, I guess. Okay. A. The point A, minus 1, 2, and the point B, 11, 6, both lie on a circle with center P. Right. The point M is midpoint of AB. Okay. So we can find M already. Given that the line L passes through M and P. Okay. All right. So that's a bisector, basically. Find an equation for L, giving your answer in the form of that. Right. So we need to find where M is, and we need to find the gradient of line AB, right? So gradient of line AB first, then maybe equals just delta y over delta x. So delta y is 6 minus 2 divided by 11 minus 1. So that becomes 8 over 10, yeah? Or 4 over 5 for the gradient. Wait, no, 12. Sorry. So that's 2 over 3. Wait, no. This is 4. Oh. Okay, my bad. Yeah. That's the gradient of line AB. So we know that the gradient of line L should be perpendicular to that gradient. So it's minus 3, right? Because we flip the fraction and put a minus sign. So that's the gradient of the line L. And then we want to find point M, right? So point M would be, we just find the average of the two coordinates there. So -1 plus 11 from A and B. Yeah, the two x's added up, divide by 2. And the two y's added up, divide by 2 as well. So this is point M. This is 10 divided by 2, which is 5. This is 8 divided by 2, which is 4. And then we make a linear equation. So y minus y1, which is, we're going to take the y from point M here, equals M, just the -3 we just found, x minus x1, which is the 5 here. And we simplify that, we get the equation in the form of slope-intercept form there, y equals mx plus c. So y equals -3x. This is plus 15 plus another 4, we get plus 19. That's it. Okay, that's question A. So part B. Okay. Given that P has coordinates of 7k, where k is a constant. Okay. Yeah. Find the value of k. I see. Okay. Let me think. Okay. So, of course, we can use Pythagoras, right? So we know that midpoint should also split the AB into halves. So we find length AB first, then maybe equals square root of delta x squared plus delta y squared, and then square root that. So this is square root of 144 plus 16. Okay, so square root of 160, right? Yeah, that's not nice. Can we do nicer? So square root of 160, that's 4 root 10. All right, so let's keep 4 root 10 first. And then we know that, so I'm going to do MB, right? So MB is just half of that. AB over 2, which is 2 root 10 instead. Yeah. And then I'm going to do, let me think through that a bit. Given that P has coordinates 7. Wait, what? Oh, I see. No, this is much easier than this. We can use the fact that the gradient of the bisector line must be like -1 over the gradient of the, so it's the same thing. So MAB equals -1 over M of the L. But the MAB here is the same, right? So it was, or wait, we can still use, yeah, we can still use ML. So ML was still the same, it's -3. So we can do delta y over delta x between M of point MP, the line that passes M and P. So this is delta y. So we're going to take point M. So 4 minus k. K here is the y coordinate of point P. Yeah. So 4 minus k, and the x coordinate of M is 5. The x coordinate of P is 7. And this is -3, right? So it's -3 equals 4 minus k over -2. So moving that, we get 6 equals 4 minus k. So k is -2. Yeah, that makes sense. Should be a minus. All right. C. Find an equation for the circle. Right, so we do x minus h squared plus y minus k squared equals r squared. Now we don't quite know r yet, but we were trying to do Pythagoras for that. Right, so we're gonna do, I shouldn't have deleted those, right? Okay, so, yeah. So MP, that's 3 marks. Yeah, I guess we gotta do that. So MP is square root. Wait, we just do MP squared because Pythagoras we need to square the MP anyway. So MP squared is the M and the P. So the M is 5, 4. So 5 minus something squared plus 4 minus something squared. I'm just doing the M first. And the P we got it is the 7 for the X, and K was minus 2. So minus 2 here for the Y. So that is 2 to the 2 is 4. That is 6 to the 2 is 36 plus 4 is 40. And then we have maybe MB squared. So M again is 5 and 4 here, squared. And then we take that from the B, which is 11 for the X and 6 for the Y. So this is 6 squared, which we get 36. 36 plus 2 again, plus 4, sorry, which is 40. Now it is quite obvious that the R is just basically 40 plus 40, which is 80. So we put 80 here. And then we do X minus H. So H is 7 because that's the center. Plus Y minus K. K is minus 2. So this is plus 2. Equals 80. That is the equation for the circle. Then I'm done. This question 7. Right. Trapezium. Okay. A. Let me check the time. Okay, I have time. Okay, it's I first, sorry. The table below shows values of X and Y, where Y equals log 10 of X plus 5 for X value between minus 1 and 4. Using trapezium rule with all the Y values in the given table, we find, okay, where K is an integer. We need to show, so we usually do the trapezium. So trapezium is basically all that. Okay, so dx approximate to be 1/2. Let me just do 1/2 here, and then times the strip width, which is 1 in this case, times we add the first y and the last y together, and all others will be multiplied by 2 added up. So that's log 6. I'm gonna have to do a second line here, plus log 7 plus log 10, 8, and that's it. So this is big brackets. I just do next line. I hope that's fine. 4, 5, wait, where's 5? There's no 5. Oh no, I've got 5, almost. Hang on. So this is log 10 of 6. You actually don't need to write 10 though, because log without the base means log base 10. So we got 5, 6, 7, and 8 here in the brackets, right? Okay. All right, so that's it. Oh, we need to simplify. We can't use a calculator. I mean, we could, but it's not going to give you the answer that you want. So all of them have the same base, right? So we would have to multiply the arguments here all together. So we would have log 4 plus log 9 plus, this is 2. So when you have 2 log 5, it's going to be log 5 to the 2. So this is log 25, right? Plus log 36 plus log 49 and plus log 81. Okay, so this is 1/2. And then you have 4. When you multiply all the numbers inside, you get 4 times 9 times 25 times 36 times 49 times 81. But you gotta, you know, square this, right? So basically it is just log base 10 of all that multiplied to the power of 1/2, because you can put 1/2 here, push it to the power of the argument inside. So I'm just going to do square root of the answer here, which happens to be a nice number. So that's the answer there, where k is an integer to be found. We found it. And then the second part, let me do that again. 4 times 9 times 25 times 36 times 49 times 81. Yeah, same number. All right, so I find the value of a such that blah, blah, blah. Okay, so this is solving a log equation, guys, not that hard. So we have log 5, base 5 of 5 minus a to the power of 2 minus log base 5 of a plus 25. And here I'm just going to do log base 5 of 5 just to make it 1, yeah? So log a minus log b, we have log a over b. So this is log base 5. We merge the two arguments. So we have this over that, yeah? And this is also log 5 of 5. So since we have one single term on each side, we can take out the log. So we would have just inside the log equals inside the log here. We want to solve for a. Yeah, I guess we have to expand. So imagine I take out log already and then I expand this quadratic function. So I get 25 minus 2 times 5 times a, so that's minus 10a and plus a squared here. And imagine after you got this down here, you move it to the other side. So multiply with the 5 here, you get 5a plus 125, right? Okay, just skip some steps here. And now simplifying, I have a squared, moving 5a to the other side, I have 15a. Moving 125 to the other side, subtract 125, I get a minus 100 here, equals 0. All right. Thinking of the two numbers multiply to 100 and add up to minus 15, that would be... I have no idea yet. Right, interesting. Did I make any mistake here? Let me see. 425, no. 8 and 12.5, no. 10 and 10, no. 2 and 50, no. 5 and 20. 5 and 20. How can I miss that? A minus 20 and a plus 5. All right, so that's it. So a is 20 or, wait, this is 5. Or minus 5. Now, we got to check, right? We can't really be happy with all the values we got here. For example, if you substitute 20 into this brackets, you can see that inside the log is going to give you a negative value. And that is not possible, right? Because log x, okay. So we reject this. So therefore, a is equal to minus 5. Got to be careful there. Okay. Next one is number 8. That seems to be a proof question, guys. Okay, so 8i is ai, not a, sorry. Student states if x and y are irrational numbers, x not equal to y, then xy is also irrational. Right. Show by counterexample that this statement is not always true. Well, let x is root 3. I'm just going to write formally here. Let x equals root 3, which is irrational. And y equals maybe minus root 3. Yeah? Where x is not y. All right, they're not equal. So xy is minus 3 times, root 3 times minus root 3. We get minus 3. And this is rational, right? So this is not true. So the statement is not true because we have a counterexample here. Okay, it's not irrational, right? Okay, the product of x, y, I mean. And number 2, prove using algebra that for all odd integers n, the value of expression that is always even but never multiple of 4. Okay, so if n is an odd integer, we do 2k plus 1, where k is an integer. Any integer, 0, 1, 2, 3, 4, so on. So n squared plus 3n plus 2 here would be, is that n cubed? N cubed. Okay, n cubed, yeah. So 2k plus 1 cubed plus 3, 2k plus 1 plus 2. So we expand this. I just happen to know that it's going to be 8k cubed plus 3 times 2k squared times 1 plus 3 times 2k times 1 plus 1 cubed. Okay, so that's it for that one. The second term here is 6k plus 3 and plus 2 for the last one. Here we get 8k cubed. For the k squared term, we get 6k squared. For the k term, we have 6 here and another 6 here, so we have 12k. And the number term, we have 1, 3, and 2, so that's 6. Okay. Now, if we prove that it is always even, so we just take 2 out here and then say that everything inside is also an integer. Right? So just factor 2 out here. So this is a multiple of 2. Therefore, it is odd. It is even, sorry. But it is also, if we take 4 out, 4, and then we do k cubed plus, what to do with that? Never a multiple of 4. We got to prove somehow that we can't really, oh no way. I made a mistake here. This is 4 times 3, so this is 12. That's why it didn't work. Okay, so this is 6k squared instead. And everything else is fine, I guess. Yeah. So if we took 4 out from this line here. Okay, I'm going to write from the asterisk here. We get 4k cubed plus 3k squared plus 3k. And then as you can see, we can split 1 into here, but then we plus 2 here outside. So if you double check this, it's going to simplify to just this asterisk line. 8k cubed plus 12k squared plus 12k plus 6, yeah? No, sorry, except that this is 2, right, yeah. Okay. Right, so you can see that because this is a multiple of 4 plus 2, right? So this is a multiple of 4 plus 2. So it's like, it's almost a multiple of 4, but not quite, because you have a plus 2 as a remainder, so to speak. So that's not quite a multiple of 4. Therefore, not a multiple of 4, right? Therefore, we conclude together n squared plus 3n plus 2 is even, but never a multiple of a 4. And then we conclude that. That's the answer then. Number 9, we are quite good. Now we are at 44. I'm going to do this page. Okay, so number 9, we have a figure here. Let's move up a bit. Figure 3 shows a sketch of a part of a curve with the equation. The curve has a turning point at point M, right, as shown in figure 3. Use calculus, find the coordinates of M, right? So we're gonna find the turning point. We differentiate the y there, right, to get dy by dx. So, but before that, we should simplify, right? So we do, if we multiply into the brackets, we get 45x squared over 5. Yes, split the fractions into 2. And then we have here minus 9x squared square root x, right? Divide by 5 as well. Let me double check that. Yeah, I think I'm happy with that. So here it would be 9x squared, right? Because simplifying that. And here we have 9 over 5. This is a half, power of a half. This is power of 2. So that's power of 5 over 2, right? 2.5. All right. So dy by dx here should be, bringing the power down, 18x. And this is 9 over 5 times 5 over 2, x to the power of 3 over 2. Just subtract that by 1. So that is equal to 18x. This is cancel, 9 over 2, x to the power of 3 over 2. We want to find m, so we equate this to 0. So that equals 0, yeah? Okay. I would maybe multiply everything by x to the power of x to the power of minus 3 over 2, or you can divide across by x. But we can also do this. Move the other term to the other side, right? And so you have so 18 times 2 over 9 equals x to the 3 over 2 divided by x, right? Just separate the variables there, the variables from the number, yeah? Okay, I'm happy with that. So 9 cancel with that, so we get 4 equals, this is x to the power of 1/2, because this is 1 subtracting 3 over 2. If square root x is that, so x alone is 16. Just square both sides. If x is 16, then we gotta find, this is x coordinate of m. So y coordinate of m would be, just substitute back in the curve equation. So 9 times 16 squared, 5 minus root 16 divided by 5, yeah? All right, so root 16 is 4, so 5 minus 4 is 1. That's it. So 16 squared times 9 over 5. Yeah, that's quite high. Anything wrong here? Okay. Maybe not. I think we're fine. Just checking, guys. Give me some time. Okay, I think we're fine. I'm just checking if this is making sense, but it has to, because yeah, y is going to be a high value, right? So we just got, if we make that a fraction, it's 2304 divided by 5. So the coordinate of m is then 16, comma, that, my answer. And then b, use algebra to find the the x coordinate of p. Oh, we put y equals 0, right? So 0 equals that. Yeah. So 5 multiply across, we get just that equals 0. So one of them is 0, which is already the origin, where the curve cuts the x-axis, but we want this one. So 5 minus square root x is 0. That means x will be 25, because if you try put that in, it's just happened to be 0, right? If you minus them. So x is 25 and nothing else. So therefore xp is 25. That's my answer. And then question C. The finite region R shown shaded in figure 3 is bounded by the curve, the line through M parallel to the x-axis and the line through P parallel to the y-axis. All right. Okay, using algebraic integration to find the area R, giving your answer in 1 decimal place. All right. So my idea is probably to, okay, let me go up to the figure here. So I'm gonna just find the area of the rectangle, right? Yeah. So area of rectangle minus the area of the one under the curve here, the area under the curve, curve M. What curve that is? Yeah, of the curve from this point right here to that, right? So it's this area basically that we need to subtract from the rectangle to get the R. But where is M again? I think we got M already, right? XM is 16, yeah. So note that that is 16 and P is 25. All right. So we find the area under the curve first from 16 to 25, right? From M to P of the curve. So we do that. Interesting. We're just gonna, yeah, okay, let's write that down first. So we have simplified the equation to this, right? So 9x squared minus 9 over 5x to the power of 5 over 2. Is that right? 9x squared minus 9 over 5. 9 over 5. X to the power of 5 over 2, yeah? Dx. That is the one under the curve, right? So integrating separately, we get, this is adding the power by 1, we get x to the 3, divide by 3, we get 3x cubed, minus, okay, so 9 over 3, adding the power by 1, we get 7 over 2, so we multiply 2 over 7, and then this is x to the power of 7 over 2. And if we substitute the bounds in, 16 to 25, we're going to get the area under the curve in that part. So I prefer to do it this way when I substitute the bounds in an integral. I have 3, so this is 25 cubed minus 16 cubed for that. And simplifying this, what do we get? 18 over 35. That's quite a heck of a fraction. Yeah. And then this is 25 to the 7 over 2 minus 16 to the 7 over 2. Okay. Ooh, okay. 3, 25 cubed minus 16 cubed minus 18 over 35 multiply 25. So 25 square root, we get 5 first and then 5 to the 7. Yeah. And then minus, again, 16, we square root first, we get 4 to the 7. That's just the way I would use a calculator with my brain. The number is too crazy here. But, okay, we give the answer to 1 decimal place. So I'm just going to do quite precise first here. So 2,834.4857. And then we're going to do R equals the area of the rectangle minus the area of the one we just found. So the rectangle there is just the width times the height. So the width is 25 minus 9 minus 16, right? Because it's just the length between M and P here horizontally. Yeah, let me check that if I got M and P right. So M is 16 and P is 25. Yeah, so we subtract them. And then multiply with the height. So the height of M, the y coordinate of M basically, which is this guy. So if we got this guy wrong, then we can get this wrong. So 2304 over 5. And then minus this, right? Yeah. Then So I equal that in my calculator and do 25 minus 16. We get 9 times 2304 over 5 minus answer. So I'm going to get 1,312 in one decimal place. That would be my answer. I'm going to maybe come back to this later. I still have number 10 here. Okay. Our time is good. Number 10, show that blah, blah, blah. So this is a trig equation. My gut tells me that we just expand. So 3 cos theta, tan theta, and then plus 2 cos theta and tan theta here. So this is just to say that we do it from the left-hand side, which usually the one that we should do. Okay, so this is tan is sine over cos, don't forget. So we have times sine over cos here. And again, this is also 2 cos theta, sine theta here times cos theta over here. Cos cancel with cos, so we get 3 sine theta plus, interesting. So it's not canceling here. Right. Okay, so we should get, this is 2 cos squared theta over sine. Right. If we, let me check. Okay. Yeah, I'm guessing that we should make everything sine, right? So if I expand this, I'm going to get 3 sine squared theta plus, and then here I'm going to get 1 minus sine squared theta. So this is basically merging the fraction, guys. So I multiply this by sine over sine, yeah? All right. So if you simplify all that, you get 3 sine squared here minus 2 sine squared here. So I have a sine squared here, hopefully. And then plus a 2 here. And then over sine here and over sine here. So that's it. So this is sine theta plus 2 over sine theta as required. Just go with the leap of faith, guy, because you'll get it if you try. Keep trying. Hence solve for that. Okay, yeah, we're going to compare then, because we already proved that the left-hand side of the equation in B here is just exactly sine, in this case would be x plus 2 over sine x, right? And then we put it to equal 4 sine x minus 5. Yeah, because they say that it's equal to that, so we just put it. Seems like we can multiply everything by sine, right? So sine squared x plus 2 equals 4 sine squared x minus 5 sine x. Simplifying every term, maybe move to the right and writing to the left here, if you are not confused. So we subtract this from this, basically. And then we get a minus 5 sine x. Then to subtract the other side, I get this, equals 0. This is basically quadratic. All right? So I would like to factorize myself. I mean, without a calculator. See if I can do that. So it's a 2 and a 1. So there you go. 2 and a 1 minus and plus here. There you go. Bam. So one of them is sine x equals minus 1 over 3. Or the other one seems to be no solution. No solution here. Okay. Because sine x cannot be greater than 1. Okay, we're going to solve for this. We're going to use cast diagram, right? So we're going to do 2 pi radians as the bound. So yeah, I think there's just 2 answers. So x equals, I can already do arc sine already in radian, minus 1 over 3. So we get minus, not minus. So this is, we got to convert that into, okay, let me do arc sine of 1 over 3. This is a basic angle. It's not 0.339. Yeah, if you change this to a plus, you're going to get that, yeah? 9, 3 significant figures, so we do 5 maybe. So that's my basic angle in 5 significant figures. And then x would be 2 pi minus that angle, so we put this to alpha first maybe, minus alpha. Or the other one is pi plus alpha. Yeah? So it's in the quadrant 3 and 4 if you can imagine the cast diagram for sign of negative value. So we're going to do answer for that. And then we have 2 pi minus answer. Okay, so we get 5.94 here. And gotta do that again, 0.33984 plus pi. So that would be 3.48. Yeah, that's it. That would be my x values. That's it. That's done. Do we have anything left? So we are done with the paper. Just at 1 hour, guys. Okay. Now, am I happy with everything? 99% maybe? I'm not sure. Maybe 95%. Would I like to double check here? I don't think I have time. So if there's anything wrong, I will just comment. But otherwise, yeah, that's it for the paper. Wasn't too bad. Oh, actually, let me check this question 9, right? Because the numbers seem weird. Yeah, let me just check my working. I don't need to double check that much because I always check as I go, right? So that's my philosophy there. Always check as you do. So we multiply in here. Yeah, so this is 9 times x squared. This is x to the 5 over 2. That's 2.5. Differentiate. Yep, I'm happy with that. Okay, and then equate that to 0. Move that to the other side. Move that. So we get 4 equals x that. So xm is 16. Yeah, 16. 16. And then ym, we find that by just putting x of 16 into the equation. So we get that whole lot. So 16 squared times 9 is 2,304 over 5 there because we have an over 5 there. So yeah, that's m. And then for b, we put the whole thing to 0 there to find the other, the coordinate of, the x coordinate of p, which should be 25, right? And then we're going to integrate that. So yeah, I'm just checking the integrand here, guys. Okay, I'm happy with that, I think. Yeah, so x of 3 over 3 is 3x cubed. 2 over 5. Oh, 2 over 7, sorry, yeah. So this is plus 1 first, we get 7 over 2, and then 2 over 7. So that's 18 over 35, that should be fine. X to the power of 7 over 2. Yeah. I'm going to do this line again, yeah, just in case. So I think I substituted, right? So 3 brackets, 25 cubed minus 16 cubed, close bracket, minus 18 over 35 times, open bracket. Okay, I'm going to put everything, right? 25 to the power of 7 over 2. And then minus 16 to the power of 7 over 2 as well. Close bracket. Still the same value, right? Yeah. And then that's the width and the height of the rectangle, 25 minus 16, we get 9. So I have 9 times 2304 over 5 minus 2834. Yeah, that's about right, 0.48. So yeah, the 1 decimal place. So I think I'm gonna stop there, guys. All right. Okay, let's mark the paper together. This is the mark scheme for P2 January 2025, right? Let's make a start. That's my first question, and this is the mark scheme. Okay, so the first one, 85, 10, 8, 8, 10, 0, 8, 8, 0, that's fine. Second question, where's the second one? Okay, so it's, okay, so constant term, 256, and then minus that. So, okay, let's check term by term. Yeah, got all of them. 0.0 minus 0.01. Okay, that's fine. Number 3. Okay, so number 3a, it's y equals 40 to the power of over x squared, and then I got the this one. This one is off by a factor of 2. Okay, so I missed something. The surface area. I think the surface area. Yeah, okay, yeah, I think I know. I forgot that there is no lid. This is an open top container. And somehow I got 2 of these, so this is wrong. This one should be 1. All right, so how many marks did I lose here? Let's see. 3a. DM achieved an expression for a. Substitute there. Okay, which may be implied by a correct expression for a in terms of x. Right. Okay. Wait. I get a mark for closed container? I did. Yeah, right. Okay. Yeah, it says here. I got a closed container here. So right. Okay. All right. So I'm just gonna give myself a mark there because I got it. I think what it says in the mark scheme. And then B. So yeah, B. So B we just differentiate. Yeah, this is a closed container case. Yeah, I do get a closed container case. Right. So this is 2.99. All right. Okay then. Right. Yeah. 30. Ooh. Somehow I got 38 here, but okay, let's check this. This is 640 over x squared. Yeah, okay. X cubed. That's fine. And then I substituted. Somehow I got a different number here. It's not 36. I got 38. Let's see if I have that mark there. So for the closed container, yeah, which one did I sub? I think I subbed the whole thing in there. So let's actually check in the calculator again. So I sub the exact value of 320 over 12 cube root. Yeah, so let's try again. So cube root fraction 320 over 12 equals, so I'm going to put that as the answer first, and then 12 plus 640 divided by, what's that? Oh, it's 640 divided by the answer, right? Wait, what? Oh, that's the value of x, right? Okay, so this is answer cubed. 36 exactly. Oh, I missed that. Okay, let's see if they condone this. Yeah, I got 36, not 38, not 36 somehow. Calculator error. I'm not gonna give myself a mark here, otherwise this say that is a minimum because this is greater than 0. Yeah, I'm gonna be harsh to myself, -1. That's fine. 4, I equals 0.4, a equals 45, that's fine for number 4. Number 5, Yeah, I got this equation fine. And A was -1, B is 8? What's wrong with that? I got 72. That's why the number was so weird. Okay, so let me check my working here. I think I did use that equation to find B. And then I move A to the other side. I forgot to divide by 9. Oh no. Yeah. So I lost 1 mark here. Right, hang on. Substitute A -1 in that. I substitute kind of a wrong equation because yeah, it is supposed to be dividing by 9. So I gotta lose 2 marks here to be harsh. I'm being fair, right? Okay, and yeah, I think I got the method there because I try to factorize this, but I'm not sure the second accuracy mark here if I do get. So let's see. Achieve the correct quadratic factor. I didn't achieve that. Fully factorized, so I lose another 2 marks here. That's already quite hurting to me. Yeah, I lost 4 marks already this paper. See if I lose any more marks here. Okay, k -2, that's fine. I just saw that. This is fine. And this is also fine. Phew. Number 7. Oh, this one is another wrong one then. What is that? I think it has to be something to do with the thing I got inside here. Yeah, 5, 6, 7. Oh, this is not 8 squared. This is 9 squared. Cause I do the, because each of them multiplied by 2, right? Yeah, this should be, so you see each of them is like, hang on. Each of them is like squared, right? Because you have a 2 here, so I put 2. I expanded 2 inside every term, so I got 25 for log 10 of 5, 36 for log 10 of 6. And then somehow, this is supposed to be 8 squared, but that is a silly mistake. That's stupid. Yeah. So I think I got the first mark. Let's see if I do get the method mark for 7i there. Attempt some correct log work seen at least once within an attempted trapezium rule. This will usually be for correct use for addition law. Yeah, okay, I did attempt that, but I didn't get the right accuracy here, so I lose 1 here. And then A was -5, so that was fine. I have now lost kind of 5 marks. If I go any further than that, I think I'm not going to get 100 now, guys. UMS, I mean. Okay, provide counter example. I think this works, yeah. Doesn't say it can't be negative. It doesn't say it can't be negative, so that's fine. Yeah, and we put 2k plus 1 here, where k is an integer. And then, yeah, we did that. We put that plus 2 right here. Okay, which is even but not a multiple of 4. Yeah, okay. Yeah, we got it. And then number 9, so it's the area here. So it's 16. Yeah, I think that's fine. Is the fraction for that one. And then for B, X is 25. This is, yeah, so that's all fine for number 9. Number 10. This is proven, yeah. 3.48, 5.94. So yeah, that's fine. And that's it. So I lost 1, 2, 3, 4, 5 here. 6 actually. Wait, don't tell me there's okay, that's 6 marks. So 90, 69 out of 75. Well, that's not so good actually. Okay, somehow I haven't managed to do super well in P2, have I? But let's see the okay, let's look at the grade boundary again. Yeah. So I'm going to change that to pure 2 because I just marked my pure 1 paper. Okay, still managed to get at least 100 UMS there. So that was fine. All right, so let's have a look at the feedback. Yeah, I need to give feedback on this paper because this one I haven't quite seen the style like this, but it's not hard. It's just rare, maybe. It gives you the series. It asks you the number of terms. You just have to play around with the formula, right, for this one. And that was fine. Yeah, this one, don't be alarmed by just seeing that state the value of x that should be used and there is no need to carry out this calculation. It just doesn't require you to show any working, but it doesn't mean that you cannot, right? It doesn't mean you cannot show the working. You can, because you need to probably equate that. I mean, if it's not too obvious for you, then maybe you need to equate 2 minus 5x equals 2.05, right? And that's fine. So don't be alarmed by just that. This one, yeah, I made a flop. Forgot to see, but I wonder why they give you the mark though. Maybe because there is the bottom surface anyway, looking inside. So I don't know, maybe they give it to you. But here we go. But A is the sheet metal, the area of the sheet metal used to make the container. But there you go there. Still managed to get the marks. Yeah, so this is straight differentiation question in P2. I don't think that's too hard. Just gotta be careful, guys. And somehow I made a calculator error here, which I shouldn't have, right? And I was harsh to myself, so I didn't give myself marks there. Yeah, this one, put it to formula straight, and there's nothing to, be confused about here. It's just simultaneous equations. But the way you solve simultaneous equations for this one is maybe you don't want to. It's not always about making something the subject and substitute. So in here, I didn't just substitute A or R. I just substitute the whole A over 1 minus R at 75 here to that, and it will make it much easier to solve the equation, right? If you didn't do this, maybe you need some more lines to, carry out the solving steps, right? Yeah, this one, a silly mistake. Another one, I forgot to divide by 9. Maybe I was a little on the edge, so it's like I was a bit reluctant to, I don't know, I'm making excuse here, which I shouldn't. All right, I was just silly. All right, so that was like a follow-through error here. Fatal, right? This is fatal. So you don't want to make any silly mistake in the middle of the question, because that can affect the other questions along the way, right? This one was fine. I just got an idea that you probably didn't have. I probably didn't have to do this, because I could have just substitute 7 here into the linear equation I got, and I would have got -2 as well. So I didn't think of that. Sorry about that. Okay. And yeah, this is a circle equation, so that was fine. This one, another silly mistake. I made 3 silly mistakes now in this paper. Okay, this should be 64. And if I recalculate that, I think I would get the right answer there. And yeah, this one is something you should note, that when you solve a log equation, the solutions to the variable don't have to be always a positive number. Because what must be, what is the right way of thinking of which one is a right answer is to substitute the solutions you get to the equation, the original equation. And if you see that the argument of the log gets negative or 0 even, then that's not valid, right? So you know how to maybe check the answer for a log equation later on, right? It's the A here in this case doesn't have to be positive always. I mean, this case you can see that if it's like a positive number larger than 5, then is not a valid answer. But on the other hand, if you have like a negative 10, it still is a possible value, a possible answer, right? So this is another point I need to stress here, and you should be careful about this, right? So always check valid solutions, the validity of the solutions in a log equation, always, yeah. Okay, and this is fine. Yeah, this is proof. So, I mean, I could have gone for root 2 and say root 8. So they are different irrational numbers. They multiply to get root 16, which is now 4. That's still another counterexample proof there. And yeah, this is fine. So the key trick here for proving that something is a multiple of something or not is that when you can factorize, let's say a multiple of 2, if you can factorize 2 out and you can write 2 times some integer here, that means it is a multiple of 2 and hence even here. But if you factorize some number out, in this case 4, and you have a remainder, so to speak, outside the first term, it is a multiple of 4 plus 2, which is not a multiple of 4. If you didn't know this, then you should, because that's how we prove being or not, whether a number is a multiple of something or not. That's how you prove it. So if you want to prove that it's not a multiple of 5, for example, you can do a multiple of 5 or like 5 times some brackets and then plus 1 or 2 or 3 or 4, right? That's how we prove not being a multiple, right? So that was fine. This one is fine. Yeah, everything is fine here, just integration. So got to be careful with all the terms there. You need to expand it first. This one, yeah, need a little bit of steps to prove until what they want here. This one is another trick equation to solve, so nothing so special here if you have done some papers. All right, guys, so that was it. So I hope that's useful. See you in the next one.